Now we shift from why to how. One of the most convenient ways to implement Google Consent Mode v2 is via Google Tag Manager, GTM. GTM provides a centralized way to manage all your tags, and it has built-in features to help with consent. Let's walk through the integration conceptually. Enable consent in GTM. First, you should enable the consent overview in your GTM container settings. In your GTM account, go to Admin or Container Settings and check the box for Enable Consent Overview. This will activate GTM's consent management interface. Once enabled, you'll notice new options related to consent in your GTM workspace. Specifically, you'll get a consent overview screen accessible from the tags section, which lets you see and edit consent settings for all your tags in one place. Consent initialization. Trigger. GTM introduces special triggers for consent. The most important one is consent initialization. This trigger is designed to fire before any other tags on the page as early as possible so that you can set up your default consent state. When integrating consent mode, you typically create a tag, often using your consent management platform's template or a custom tag that runs on the consent initialization all pages trigger. That tag's job is to communicate the initial consent state to Google's GTag system immediately when the page loads, before any tracking tag tries to fire. For example, it might tell Google, hey, until I hear otherwise, assume ad storage denied, analytics storage denied, etc. We'll configure these specifics on the next slides. Why is this needed? Without setting a default, a tag might fire and set a cookie before knowing the user's choice. The consent initialization trigger ensures no other tag jumps the gun. It's a safeguard so that, say, your GA4 tag doesn't drop a cookie if the user hasn't consented yet. We want the consent state established first thing. Using a CMP with GTM, many consent management platforms, CMPs, provide GTM tag templates to make integration easier. For instance, if you use OneTrust, CookieBot, Compliance, etc., you might find a template in GTM's community template gallery for that CMP. These templates usually handle the heavy lifting, displaying the consent banner, capturing user choices, and using GTM's consent API to set or update the consent status accordingly. The recommended approach is indeed to use a CMP tag template in GTM. Steps often include: add the CMP's tag via the template. Choose it from the gallery. Configure your CMP ID or settings. Set the default consent within that tag, usually all denied until user interacts. Fire it on the consent initialization trigger so it runs first. The CMP tag will then handle showing the banner. When the user makes a choice, the tag can call GTM's consent API or fire events to update consent. If you don't have a CMP and built your own consent banner, you can still integrate with GTM. You'd create a custom HTML tag or use gtag.js code that sets the default and listens for user choices, then calls the consent commands accordingly. Consent checks on tags. GTM allows you to specify on each tag what consent it requires to run. This is in the tag's settings under consent settings. For example, your GA4 tag will list that it's linked to analytics storage, and perhaps add storage if using ads features as built-in checks. You can also add additional consent checks if needed, though for Google tags the built-ins are usually sufficient. By configuring these, you ensure that if the user denied consent for a particular purpose, the tag will automatically not fire or will adjust its behavior. In practice, if you're using official Google tag templates, GA4, Google Ads conversion, they already respect consent signals. GTM's built-in checks reflect that. They know to look for granted consent. But for any custom or non-Google tags, you may use the additional consent checks to conditionally prevent firing. Putting it together, once GTM's consent features are enabled and configured, Step 1. A user lands on your page. The GTM container loads. Step 2. The consent initialization trigger fires your consent tag immediately. That tag sets all relevant consent states to default, likely denied. Now, Google's global tag environment knows the default, it's no consent, which is the safest assumption. Step 3. GTM then proceeds to other tags, like your GA4 page view. Since consent is denied at this point and GA4 tag is consent aware, if you're in advanced mode, it might fire but without cookies. If you configured basic mode, no fire without consent, GTM would hold it until consent is granted. We'll clarify basic versus advanced soon. Step 4. The user sees the consent banner, which our CMP tag likely displayed. Suppose the user clicks Accept All. The CMP will then update the consent state. In GTM, the CMP's tag might trigger a GTag consent update call or use GTM's API to flip those states to granted as appropriate. Step 5. GTM registers that update. It can then allow tags to fire that were waiting or ensure future events now include consented data. Cookies can now be set by GA add ads. Step 6. Throughout this, Tag Manager's consent overview screen would show which tags fired or were blocked due to consent, helping you debug and ensure compliance. The integration essentially means you're wiring your consent banner into Google's tagging system via GTM. GTM is the mediator that makes sure no tag misbehaves relative to the user's choice. It's a powerful approach because it doesn't require hard coding a lot of script in your site's HTML. You can manage it all in GTM with version control and testing in preview mode. One more thing, if you use GTM's server-side tagging, consent mode still applies, but you'd handle consent at the client side before sending to the server container. That's an advanced topic, but worth noting if your setup is more complex. In conclusion, GTM integration for consent mode involves enabling consent features using a consent initialization tag, usually via a CMP template, and configuring tags to respect consent. Google Tag Manager provides the tools to do this systematically so that you remain compliant and your analytics ads tags only do what they're allowed to do given the user's consent status. Next, we'll go through a concrete step-by-step enabling of Consent Mode v2, which will make this even clearer. Let's break down the implementation process into clear steps. We'll assume you're using Google Tag Manager, which is the case for most folks following best practices, but we'll also note the GTag.js equivalent for those not on GTM. By following these steps, you can get Consent Mode v2 up and running on your site. Step 1. Implement a consent banner, CMP, prerequisite. Ensure you have a consent mechanism on your site, a banner or pop-up that asks users for consent for cookies or tracking. This can be a commercial consent management platform, CMP, or a custom-built solution. It should allow users to at least accept or reject cookies for analytics and ads, and ideally offer granular choices, e.g., accept analytics but not ads, etc., to align with GTM v2's signals. If you don't have this, put one in place first, because consent mode relies on capturing user input. Many CMPs are available. Choose one that is Google CMP partner certified if possible, as it will likely support GTM v2 out of the box. Step 2. Enable consent mode in GTM. As discussed, go to GTM admin to container settings and enable the consent overview. Next, in your GTM workspace, add a consent initialization trigger, built-in trigger. Usually, GTM already has one called Consent Initialization All Pages. This trigger will be used in the next step. If not using GTM, you'll be adding code manually to your sites. Step 3. Set default consent state before any tags fire. Create a new tag in GTM to set the default consent state. If using a CMP template, add the CMP's tag via the template gallery. Search for your CMP name, add it, configure it as per the provider's instructions, select languages, styles, etc. as needed. In its settings, set all Google consent types, add storage, analytics, storage, add personalization, add user data to denied by default. This means until the user says otherwise, we assume no consent, which is the safest default legally. For example, a configuration interface might have you add those fields with denied. The image below shows how that looks in GTM. Default consent settings in GTM. The screenshot above shows a GTM tag template where all consent parameters, add user data, add personalization, add storage, analytics storage, etc. are set to denied by default. This reflects that initially we are not allowing any tracking cookies or personalized data usage until the user consents. Step 4. Configure Google tags to honor consent. Good news, if you're using official Google tag templates, GA4, Google Ads, Floodlight, etc., they automatically respect the consent signals. For instance, the GA4 tag will see analytics storage, denied, and won't drop cookies. The Google Ads conversion tag will see AD storage, denied, and not use or write any cookie data, etc. However, double-check your GTM tag settings. Edit each Google tag, GA4 ads, etc. Scroll to consent settings in GTM. Ensure that under built-in consent checks, it lists the relevant consents. You should see analytics storage for GA4 and both ad storage and analytics storage for ads conversion if it uses both. GTM likely has them preset. If a tag requires additional consent, say a non-Google marketing tag, you may use require additional consent for this tag and specify which consents it needs. In summary, make sure no tag is set to fire ignoring consent. GTM's consent overview screen is helpful here. It will highlight any tags that are not configured for consent. Ideally, all tags dealing with personal data should either have built-in consent checks or additional ones configured. Step 5. Update consent on user interaction. This part is usually handled by your CMP logic. When the user clicks accept or reject or makes granular choices, the CMP should trigger an update. In GTM, the CMP template tag often automatically calls something like gtag consent update analytics storage. Granted, add storage. Granted, add personalization. Granted, add user data. Granted, if the user accepted all, or a mix of granted, denied if they only allowed some categories. For example, if they allowed analytics but not ads, it would set analytics.storage to granted, and add storage, add personalization, add user data to denied. If doing manually, you can use GTM's data layer events or direct calls to implement this. E.g., on accept button click, push an event that triggers a GTM custom tag to call the consent update. The important thing, when consent updates, Google's tags need to know about it. Consent mode is dynamic. It can switch states. Google recommends that the update command runs on the same page as the interaction before any navigation so that the current page's tags and any subsequent ones can act on it immediately. Step 6. Testing and publish. We'll delve into testing next slide, but as part of the setup, preview your GTM container. Use Tag Assistant or GTM Preview to simulate a user flow. See that default consent is set. Tags should initially be restrained. Then simulate giving consent and see tags fire properly. Once confirmed, publish the GTM container live. By following these steps, you effectively wire up consent mode v2. A user arriving sees your banner and behind the scenes. Initially, Google tags are held back or limited by default denied state. After consent is given, tags operate normally and cookies can be set from that point on. If consent is never given, user ignores the banner or rejects, Google tags remain in their limited state. No cookies, only minimal pings if advanced mode. One more advanced note. Basic versus advanced mode configuration. If you intend to use basic consent mode, meaning no data collection at all until consent, you need to ensure that your tags don't even send the anonymous pings. In GTM, that could mean not firing certain tags until consent granted triggers occur. Many CMP templates allow choosing advanced or basic. The cookie information CMP, for example, has a setting where advanced mode will load tags immediately with no cookies if denied, versus basic mode will suppress tags until consent. We'll cover testing how these behave soon, but the step-by-step implementation above is largely the same. The difference is simply whether you allow the tags to fire in a limited way or not at all pre-consent. You've now set up consent mode v2 on your site. Next, we will talk about configuring specific behaviors for the key settings, AD storage, analytics, SAF storage, etc. in more detail, and then how to verify everything is working correctly. On this slide, we'll zoom in on the two core settings from consent mode and discuss how to configure their default and updated behaviors, ad storage and analytics storage. These are the original consent mode parameters and remain the primary controls for on-page behavior of Google tags. Ad storage. This setting governs access to storage, like cookies, local storage, for advertising purposes. It affects things like the Google Ads conversion tracking cookie, Chash GCL AW, Google Marketing Platform cookies, and remarketing tags. Default behavior. Typically, you will set add storage to denied by default for users until they consent. This means when the page first loads and the user hasn't made a choice yet, or if they ultimately refuse, Google's advertising tags are informed that they cannot use cookies or other local storage. In practice, if add storage is denied, no new advertising cookies will be written. For example, the conversion linker tag in GTM will not set the add.gcl cookie on the user's browser. No existing advertising cookies are read. If the user had a Google Ads cookie from before, the scripts won't read it or send it in requests. Services like Google Ads or Floodlight may still send an anonymous hit, depending on advanced mode, to register that an event happened, but it won't include any cookie IDs or other identifiers. The effect is that you don't get user-specific ad data. For example, no adding user to remarketing lists, no unique identifiers to connect an ad click to a conversion in the usual way. Instead, Google has to later use modeling to attribute conversions. Updated consent granted. When a user gives consent for ads, in other words, they allow marketing cookies or personalized ads, ad storage is updated to granted. From that moment, Google Ads marketing tags can set and read cookies normally. The conversion linker will drop cookies that help attribute ad clicks to conversions. If a conversion event fires now, it can include identifiers like the Google Click ID or a device ID on mobile apps because consent allows it. Remarketing scripts can add the user to audiences, frequency capping info can be stored, etc. Essentially, full functionality is restored. If the user moves to another page or refreshes, they'll now carry those ad cookies with them, enabling tracking. One nuance: if you had an event fire while ad storage was denied and then the user consents on the same page, advanced mode scenario, Google's scripts may refire or flag the earlier event now as consented, though conversion tracking usually cares mainly about the final conversion event. But GA4 will retroactively mark hits on the same page as consented. Analytics storage. This controls storage for analytics purposes, which mainly means the cookies for Google Analytics, like the client ID cookie. Default behavior: set analytics storage to denied by default. So until user consents, Google Analytics, GA4, will not store or read any analytics cookies. GA4's behavior with analytics storage denied. It will not set the #GA cookie, which normally holds the unique client identifier. If advanced mode is on, GA4 will still send a page view event but with no client cookie. GA will use a short-lived identifier just for that session/ping. This means GA4 collects a hit but can't recognize if two hits are from the same user except through modeling. As a result, the analytics data for unconsented users is extremely limited. GA might not track their session duration accurately, cannot tie multiple page views together as one user journey, and cannot do user ID-based analysis. However, aggregate counts like a page was viewed or a conversion happened can still be incremented. If you're using basic mode and blocking GA entirely pre-consent, then no GA data at all is collected until consent. Updated consent granted. When the user accepts analytics cookies, analytics storage becomes granted. GA4 will then set its client cookie and begin full tracking. It can start recognizing the user as a new user from that point technically, since it didn't have a prior ID for them. From the consent onward, you'll get all the usual data: page views tied to a client ID, events attributed to that user, etc. GA4 also has a feature where if consent is granted mid-session with advanced mode, it will adjust hits on the fly. Hits that occurred just prior on the same page, e.g. page view, can be associated with the now set client ID going forward, at least for that session. However, GA4 will not magically recover the full history for that user. Any hits before consent, without identifiers, remain anonymous and only used in aggregate. The key is that from now on, analytics data is complete for this user, and any subsequent page loads, which now find a GA cookie. How to configure these in practice. In your GTM or code, you explicitly set these defaults and ensure updates happen. We already did default config in step 3 of the previous slide, denied for both. For updates, your CMP should map the user's choice. If user says allow analytics, then include analytics storage, granted in the update call. If they say allow ads/personalization, include ad storage, granted. and similarly the other fields like ad personalization. If they only allow some, you might update one and not the other. For example, a user might consent to analytics but not ads. Then your update might be gtag consent update analytics storage. Granted, add storage. Denied, add personalization. Denied, add user data. Denied. This flexibility is why GCM v2 is granular. Under the hood, if analytics storage is granted and AD storage is denied, GA will function normally, but Google Ads scripts will remain restricted. Google's tags handle this mix gracefully. You might see in Tag Assistant that analytics pings have one consent state and ads pings have another. The role of ad personalization and ad user data. Though the slide title mentions only ad storage and analytics storage, it's worth noting what happens with the new signals. Ad personalization and ad user data by themselves do not change on-page behavior. They are essentially flags that get sent along in the network requests to Google. Google uses them on their back end to decide, for example, if a conversion can be used for personalized ad modeling or if a user can be added to a list. However, typically if a user consents to ad storage, they likely consented to personalization too, depending on how your banner is phrased. But some banners might allow a user to opt out of personalized ads, but still allow basic ads tracking. In that case, you might set ad storage granted to allow basic conversion measurement cookies, but ad personalization denied, meaning use the data only for conversion measurement, not for personalizing remarketing. Google's tag would still set cookies, but Google Ads on the back end would know not to use that user's info for building remarketing audiences. This is a somewhat niche configuration but illustrates the control. Similarly, ad user data is about using user data, like if you send first-party identifiers or Google Signals data. If that is denied, Google will refrain from using any such data even if you pass it. For beginners, usually you'll treat all ad-related consents as one combined thing. Marketing consent covers all. If so, all ad fields go granted or denied together. Now all four are true. Immediately, the GA4 tag sets a client cookie and logs a consented page view event. Maybe it logs a consent event internally as well. The Google Ads conversion tag, if on page, can drop a cookie or match an existing one and log a conversion with full info. If the user was in the middle of doing something like adding to cart, any event tracking tied to that can now link to their ID going forward. Essentially, the site has moved from no tracking to tracking enabled smoothly. If the user had clicked reject all, we'd simply keep everything at denied. The user's browsing will be tracked only in the most minimal anonymized way, or not at all if basic mode. You'd see in your analytics lower numbers for such users, because either it's not tracking them or they're counted in modeled data. Double-checking config. A handy tool is Google's Tag Assistant debug mode. It shows you what the consent state was for each event. In Tag Assistant, you can see something like on-page default, AD storage, denied analytics storage, denied, etc. On-page update after an accept, AD storage, granted, analytics storage, granted, etc. This confirms that your configuration works as intended. To summarize, configuring default and updated behaviors for AD storage and analytics storage means default denied, no cookies, until user says yes. Update to granted when user consents, thereby allowing normal tracking operations. Ensure your GTM or code properly flips these states based on the user's choice. Understand that denied means limited modeled data, granted means full data capture. By carefully handling these two settings, you abide by users' consent and maintain as much functionality as possible in each case. And thanks to consent mode, even when they're denied, you're not completely in the dark. You still get aggregate insights without compromising privacy. Implementing Consent Mode v2 is only half the battle. You also need to test and validate that it's working correctly. Proper testing ensures that you're truly not dropping cookies when you shouldn't and that you aren't losing data when consent is given. Let's go through some best practices for testing and validating your consent mode setup. Use Google Tag Assistant Debug Mode. Google provides a Tag Assistant debug tool, accessible at tagassistantgoogle.com, that is extremely useful for consent mode. When you run Tag Assistant on your site, it will show a timeline of events and a special consent tab for each event. Here's how to use it. Go to the Tag Assistant site and enter your URL. Make sure you've deployed your GTM changes in preview or live. Tag Assistant will open your site in a debug mode. Perform a test scenario, e.g., first, do nothing with the banner. In Tag Assistant's interface, look at the earliest events. They often have names like consent events at the very start. Click an event and choose the Consent tab. Verify the on-page default consent values are what you expect. You should see AD storage, analytics storage, AD personalization, add user data all set to denied initially. If any says granted by default and you intended it to be denied, that's a problem. It means default isn't being set properly, or maybe a tag fired too early. Now, in your test, interact with the consent banner. Click Accept All, or a particular choice. In Tag Assistant, find the event corresponding to that action. There might be another consent event or at least subsequent page events. Look at the on-page update column. This should show the changes after the user's choice. For example, if they accepted all, you'll see granted for each field in on-page update. Tag Assistant will also list which tags fired and which were blocked due to consent. Check the Tags tab in the summary. For any tag that did not fire, it will say why, e.g., blocked by consent. Make sure this matches expectations. E.g., if user denied, GA4 main tag should be blocked in basic, or at least not setting cookies in advanced. If user accepted, tags should fire. Using Tag Assistant in different scenarios, accept versus deny versus ignore banner, helps ensure all branches work. It's a good idea to test partial consents too if your banner allows, e.g., accept analytics but deny ads. Browser Developer Tools. Another way is manual checking via Browser Dev Tools. Cookies. Open your browser's developer console, typically F12 or right-click. Inspect, then go to Application or Storage tab to see cookies. Before giving consent, confirm that no Google Analytics cookies, etc., and no Google Ads cookies, GCL, etc., are present. If you see any appear even though you haven't consented, something is wrong. A tag might have fired too early or a default not set correctly. Network requests. In the Network tab of DevTools, you can watch the requests. Google Analytics requests to collect endpoints, and Google Ads requests to page ad or Google Ads services often have parameters. With consent mode, look for a parameter GCSS in GA4 or ads requests. As Simo Ahava noted, GCS encodes the consent state. For example, GCSS G100 means both ad and analytics storage were denied at the time of that hit. G111 would mean both granted. This is more of a technical check but can confirm that the signals are being sent. In V2, there's also a GCD parameter that encodes the new signals. Also examine if identifiers are present or not. For instance, in a GA4 request, with no consent, you shouldn't see your client ID, usually passed as CID or similar. With consent, that should appear. Check that when you click accept, subsequent network calls include cookies/IDs. This method is advanced but ensures nothing sneaky is happening out of order. Test in different regions. If your site serves globally, you might have region-based consent behavior. Some CMPs only show the banner in EU, for example. Use a VPN or Tag Assistant's location simulation to test from an EU IP versus a non-EU IP. Ensure that for EU, consent defaults are applied. For non-EU, if you allow tags to run without a banner, that's up to your policy. Some sites don't prompt US users at all, then you might default to granted outside EU. The key is your configuration might have region logic, so validate each case. Validate with CMP logs. If using a CMP, many have dashboards that log consent rates and even individual consent transactions. Check that when you gave consent, it was recorded properly, and that when you denied, it shows as denied. This mostly validates the CMP side, but indirectly ensures GTM got the message. Cross-device and incognito testing. Always test in an incognito, private window, or after clearing cookies. This ensures you simulate a first-time visitor with no stored preferences each time. Also test on mobile devices and different browsers. Sometimes things like Safari's ITP, Intelligent Tracking Prevention, might block third-party cookies anyway, which can complicate testing. But that's beyond consent. Just be aware that in Safari, even if you consent, some cookies might not persist due to browser restrictions. Simulate sequences. One scenario to test is user initially denies, then later changes mind, or vice versa. For example, user clicks deny all. Check that no cookies are set and no personal data sent. Then user goes to site settings if you offer a way to adjust consent and chooses to accept. Check that now cookies are set from that point on. GA4 should treat that as a new consented session starting. Google Ads should be able to attribute future conversions from that point. Also test if a user accepted, then maybe withdraws consent if your CMP API can do that. Consent mode should update back to denied, and ideally, your tags should stop or drop cookies. Though removing already set cookies is tricky. Consent mode doesn't auto-delete cookies, it just stops using them. Some CMPs will delete cookies upon opt-out. Monitoring Tag Assistant for warnings. Tag Assistant will also show warnings. One common warning is a tag read consent before a default was set. If you see that, it indicates a race condition. Some tag fired before your default was applied. This is important to fix. It might mean your consent initialization tag wasn't first, or maybe you had a hard-coded script outside GTM that fired too early. Resolving this might involve moving scripts around or ensuring the GTM container snippet is as high as possible in your page head. Consent mode verification tools. Google's documentation itself, as we saw, has a troubleshooting guide. There's also a Chrome extension version of Tag Assistant you can use.